Hey guys, so I am proctoring PSATs all day today. So today's lesson and work is asynchronous. So if you want to do it later today or first thing in the morning, I released both at 7:30. So your classwork and the homework should be there in the Google Posts. Our objectives today are to solve application using rational equations. So we're going to cover two types of applications using rational equations. So we're also going to be solving them as we solve distance and work problems. So both of these are topics on standardized testing, SATs, ACT, ASVAB testing for the Army. Both of these are on it. So as a quick warm-up, you can check your homework, which was from Algebra 1, the rational expressions, simplifying, identifying excluded values, and solving some basic equations. So go ahead and check that, and if you have questions on anything, I'll answer it next block when we're back together. After you do that, you can pause this video and go ahead and solve each of these rational equations, number 1 and 2, and answer the question number 3 from physics: what is rate of speed? What formula do you use? And think of the speed limit, 65 miles per hour, when you're explaining. All right, so answer those, pause the video, and then come back. Okay, so for number 1, you should have found that lowest common denominator after you factored the denominators to be 2x times x minus 5. So make sure all denominators match. All right, so I show you the details here. You should have gotten x equals 6. If not, pause the video and take a look at that example. And number 2, that one's easy to cross multiply, or you could factor and use lowest common denominator method. Okay, and for number 2, you should have gotten x equals 10. I use lowest common denominator method. If you cross multiplied, then you had to factor and exclude the -1 because that would make your denominator equal to 0. And you should still get to x equals 10. And then question 3 from physics: what is rate of speed? Well, the rate of speed is the distance divided by time, just like 65 miles is divided by 1 hour. Okay, so you may remember from driver's ed, you did this in physics, and you also did it in Algebra 1, but distance is equal to rate times time. So these are the only notes today here and when we do work problems. So D equals RT, and where they become involved with rational equations is when you start dividing. You know T is equal to D divided by R, so that would be a rational equation, and also R is equal to D over T. So anytime you have the times equal or the rates equal, then you'll get into a rational equation. Not always. So one example would be 65 miles per hour. That rate of 65 is equal to 65 miles per 1 hour. All right, so let's start solving these examples. Example 1A, a car travels 500 miles in the same time that it takes a train to travel 300 miles. Well, right away, you know the times are equal. So we can set the times equal, and then time is distance divided by rate, and we'll have a little rational equation to solve. So we're given the speed of the car is 30 miles per hour faster than the speed of the train, but we do not know the speed of the train, so that will be our variable R. Okay, so we know the speed of the car is the speed of the train plus 30 because it's 30 miles per hour faster. So for the car, it would be R plus 30. And now you can write a little proportion. So we know time from above here is the distance divided by the rate of speed. Well, we are given both distances, 500 miles for the car, 300 miles for the train. And now we're going to assign the speed of the train is R and the speed of the car is R plus 30. So pause the video, go ahead and solve for R, the speed of the train, and then you'll just add 30 to get the speed of the car. All right, so if you didn't get the train speed is 45 miles per hour and the car speed is 75 miles per hour, here's the work above when you cross multiply. And there we did use a rational equation, right? So this is why we're linked to this unit. We used a proportion and rational equation to solve it. So with distance, remember, it's not always needed a rational equation, and you're going to see that when you solve 1B. So pause the video and try that one. Draw a little picture. It helps you put things in perspective. Okay, so for this one, we know an Air Force plane left Paris at the same time as a jet. They flew in opposite directions, so I drew two opposite arrows here. The jet flew at 280 kilometers per hour, and after after 5 hours, they were 2,200 kilometers apart. So they both flew for 5 hours. We don't know the rate of the Air Force plane. That's what we're asked for. But we do know combined, those distances equal 2,200 kilometers. So the jet, we know distance equals rate times time. We have a rate and a time. So we know that the jet traveled 1,400 kilometers when we multiply 280 by 5. And you have to excuse me, I left my pen at school today. So it's going to be a little messier than usual. And we do also know that rate times time would be 5R for the plane. And combined, if we add those two together, we should get 2,200 kilometers. So we don't even need a rational equation for this application. It's just standard linear. So go ahead and solve it. Set 5R plus 1,400 equal to 2,200. And you should get 160 kilometers per hour for the plane speed. Okay, so here's the work for that problem. And then the next type of problem we're going to do will require a rational equation each time. And those are called work problems. Okay, so for rate of work applications, anytime you do any amount of work, it takes you some amount of time to do. So just like solving equations, some of you may have solved the do now in 2 minutes, another person may do it in 5 minutes, and a third person in 10. But we're all doing that same amount of work. The time is what changes. That ratio is what we call a rate of work. So when we're talking about rate of work, these types of problems are going to be when you combine individuals together to do the same job. So each individual has their own time that it takes them to do an amount of work. So if you take an individual number 1, they can do that one job in T hours or minutes or seconds. So they do it at their own time. But individual 2, if you gave them that same one job, they would do it in their own time, maybe a little longer, a little shorter, but their own time. Now, if you combine them on a task to do the exact same job, they're still going to do that one job together, but it's going to be a combined time that they're going to take. And it's always shorter than the slowest of the 2 or 3 or 4 individuals because you're adding labor to that, and it's going to go faster. All right, so this becomes a little rational equation. You're going to be given 2 out of the 3 of these items, and you can solve for the missing 1. So the amount of work, it doesn't matter if it's 5,000 square feet you're painting, 2,000 square feet that you're painting, it's one job. So the numerator with these problems will always be 1. So let's go through an example. 2A says Mark can paint a doghouse in 8 hours. So his rate of work is to paint that one doghouse in 8 hours. Now Jane, she can do it in 4 hours. So Jane's rate of work is going to be one doghouse, the same one doghouse, but in 4 hours. So the question here is, how long will it take them to do the job if they work together? So they want a combined amount of time here if they're working together. And that's the key word you'll see when you do standardized testing. That's your hint there that you need to use a rational equation. So we're going to add Mark and Jane together, their 2 rates of work, and now we want to come up with that same one job. How long will it take? And I'll call that T, the combined time. And what you have there is one of our most basic rational equations, the one you did in middle school. Go ahead and solve it and find the time it would take them together. Keeping in mind, Jane can do it alone in 4 hours, so you should be getting some number less than 4. Okay, so you should have gotten 2 hours and 40 minutes. You're never going to answer somebody 8/3 of an hour. So if you convert it to a compound fraction, you know it's 2 hours and then 2/3 of an hour. If you multiply 2/3 by 60, you get that 40 minutes. So much less time than the lowest rate of any individual. All right, now in 2B, we have 3 different students working together. So here they said if one student can complete the decorations for the prom in 5 days working alone, so the first student's rate Our work is going to be decorating a prom. All right, so if we decorate that one prom, our first student can do it in 5 days. Our second student can do that same one prom in 3 days. And then our third student can do that same one prom in 4 days. And the question is, how long would it take them working together? So we're going to add all their rates of work together. And we're going to set that equal to the same one prom divided by what would the combined time t be. And again, it's 3 fractions, but a rational equation. Pause the video, solve, and then you'll check. Okay, so I use lowest common denominator method, and you get about 1.28 days. It's about a day and almost 7 hours. So you'll have an idea of how long it would take. And again, it's going to be less than the fastest student. So our fastest student here could do it in 3 days. We're going to be less than that because we're adding more manpower to that work. All right, so there are 2 examples of each distance and rate of work type problems. Again, keep in mind when you do the distance problems that you don't always need a rational equation, but when you do rate of work, you'll always need a little rational equation. Your job during class today is to solve the class practice. 1 through 4 are the applications. There's 2 each, 2 distance, 2 rate of work, and then there's 6 plain old equations to solve. Make sure you look for your excluded values. And then the homework also popped up. That's a few problems from the textbook. So you're going to look at chapter 9-6. That's where the textbook pages are. You're going to complete that and upload that for 2 points. The classwork, I do not need to see uploaded. All right, we're going to have a little graded classwork next block, so I'll know if you did it or not. So have a great day, and I will see you guys on Friday.